How do the past's greatest buildings measure up in the 21st century? In this series, we're going to use the most advanced technology on the planet to put history's building wonders to the test. Famous structures around the world, pored over for centuries by archaeologists and historians. We've never truly been able to uncover all of their secrets. But now, scientific breakthroughs have created an amazing new laser technology that can capture and explore these structures in a way no human eye can. For the first time, allowing us to understand some of the oldest mysteries of the engineering world. This time, the time scanners are heading to Machu Picchu to discover how the Incas built a gravity-defying city in the clouds. If you were doing this now, this would be limits of engineering.
You wouldn't be able to do it. It's too dangerous. People will get killed doing this.
And how the city built at 3 times the height of the world's tallest building could feed and water its 1,000 residents. We're going to reveal just how good yesterday's engineers really are. Peru, home to nearly 30 million people, many of them direct descendants of the Inca, one of history's most mysterious civilizations. Their empire began in the Peruvian Andes in the early 13th century and went on to become the largest in South America. At its heart was the historic city of Cusco, gateway to Machu Picchu, a royal palace complex and one of the most iconic feats of engineering in the world. It just defies logic, it defies explanation. You can understand why this is one of those places to visit before you die. Built on top of a mountain nearly 2,500 meters above sea level, this was a fully functioning city with over 200 stone buildings and almost 300 meters higher, the sacred peak of Huayna Picchu, with terraces built at an impossible angle on an almost vertical mountain face. Huayna Picchu and Machu Picchu, built by the great Inca Emperor Pachacuti. He ruled for over 30 years in the middle of the 15th century. We're here to explore how the Incas built Machu Picchu. And our brand new technology can help us do just that. Recent scientific breakthroughs mean we now have a device portable enough to travel the world and access these incredible places, and powerful enough to explore deep inside their structural secrets. The mobile laser scanner. These bounce narrow pulses of light off objects to map them with incredible accuracy. What's packed into this tiny box gives our experts virtual superpowers, collecting over 1 billion measurements to form what is known as a point cloud, giving us an incredible 3D perspective, the ability to pick up million-ton structures and move them anywhere, and use this data to take precise measurements with pinpoint accuracy, to peel back time and help us unravel mysteries locked in the past. But the real key to the technology is in the interpretation of this data. And we're seeing it through the eyes of one of the world's best structural engineers, Steve Burrows. A master of the modern building world, Steve Burrows has created such iconic structures as the Beijing Bird's Nest Stadium, Munich's Allianz Arena, and Manchester's Etihad Stadium. Steve's always wanted to explore the great engineering mysteries of the past, and now he has the technology to do it.
My job is to get into the head of the Inca engineers and figure out how they really did this.
Absolutely. We need to be Inca thinkers. We need to think like an Inca. Armed with our scanning technology, Steve wants to answer 3 key questions. How did the Inca build a city on the side of a mountain? What was the purpose of these terraces and how were they constructed? And finally, how did they supply the entire city with fresh flowing water? To aid his mission, Steve has brought along a world-class scanning team from the Center for Advanced Spatial Technologies at the University of Arkansas. Katie Simon, Malcolm Williamson, Eileen Ernenwine, and Adam Barnes.
We scanned in very challenging environments before, but this is at the top of the difficulty scale.
The team begin their scans and investigate their first question. How was a city of this size built high up on the side of a mountain? Before Machu Picchu was built, this location looked like the neighboring mountains, with steep vertical sides and covered in dense jungle.
You have the mountain with the vegetation on top. The first thing you do is remove that. Then you get down to the loose material, the loose rocks and the stone and the rubble and the soil. It's a huge exercise. It involves hundreds, maybe even thousands of people.
To unlock the secrets of this city's remarkable design, Steve thinks the clues can be found within the very rocks themselves.
Every construction site in the world, we look at how much material we got to take out of the ground, and then we think about where we're going to put it. But the basic idea is exactly the same as the builders of Machu Picchu.
To build a city in the sky, the Incas needed to take control of the mountaintops, leveling the peaks with terraces to create the foundation for their gravity-defying city. But where did they get the materials to do this? In the southwest corner of the city, the process of leveling the mountain appears frozen in time, and Steve believes it holds vital clues as to how the entire city was constructed. So he wants to scan it to see what the 3D data will reveal about Machu Picchu's origins.
The sort of rocks that we want to scan are things like this one. So you can see, this is a prepared face. Look how flat it is.
So what were these rocks being used for? While Katie takes close-up scans of the area, Adam and Malcolm scan from long range. Steve hopes the data will hold the key for him to understand the building of this city in the clouds.
Let's scan one on each side of this bit.
Sounds good. I'll go get the other one set up over there.
Okay, let's get started. Ooh, I thought that was a snake for a second.
The Incas had no written language, so no record of Machu Picchu's construction exists. But the facts that experts have managed to put together read like an adventure book. Built more than 500 years ago, it was abandoned just a century later when the Spanish conquered South America. But this mountain stronghold was never discovered by the invaders, despite their conquest of the Inca Empire. For the next 400 years, it lay hidden under dense jungle until 1911, when American explorer Hiram Bingham brought it to the world's attention. The story has it that there's actually a local kid that led Bingham along this path to this rather precarious ridge over here. And these are the actual photographs he took from this very spot. And when the world saw them, suddenly Machu Picchu was on the map. As the city was excavated, a wealth of stone buildings and terracing were discovered. Once a royal estate filled with palaces and temples, playing host to religious rituals for 1,000 residents of the royal court. They lived a luxurious life high up in the mountains, in some of the finest Inca houses ever built. Machu Picchu was a stunning city in the sky. It was the pinnacle of Inca engineering, with a water system flowing like an artery through the center of the city.
The agricultural terrace.
Now we want to discover the secrets behind how this place was built, and the scans are in. This is our tech HQ. Here the laser images have been joined together to form a point cloud. It consists of millions of tiny dots, creating an exact 3D model of the site. And being able to examine the site from every angle, Steve is excited about something he's spotted in the point cloud data. He's taken a closer look at the unfinished area of the city and thinks he's found some clues which reveal how Machu Picchu was built.
We're looking at a process here. As they actually took the rock out of the mountain and used it to build, they were actually creating the terraces. I can actually see the start here and round here of a terrace emerging from the mountain. They're taking the rock away, building the buildings, and then converting the mountain into terraces.
Steve can see that as they cleared the site of rubble, the Inca were recycling the boulders they removed to build their terraces. And our laser scans reveal the city under construction, showing how the Inca turned rocky hillsides into hundreds of terraces for their city.
It's the perfect, efficient way of building, isn't it?
Completely working with nature.
Yeah.
With our scanning technology, we've captured a moment in time, showing Steve how Machu Picchu was built. And by looking at our laser scans again, Steve realizes there's more to the city's terraces than meets the eye. He suspects they may be the key to Machu Picchu's very survival. We're discovering the engineering secrets of Machu Picchu, a magnificent mountaintop city. To survive, the Inca builders used terracing to provide farmland. However, being built over 2,000 meters high on solid rock, how could they create farming conditions in the clouds?
With all the temples and other amazing structures here at Machu Picchu, you might be forgiven for thinking that, these terraces aren't that exciting, but Steve assures me that they are the key to the entire site.
Living in such an inhospitable place, growing food was vital. Structural engineer Steve wants to understand how the Incas managed to successfully cultivate farmland so high up, and at this angle. How could they build a terrace strong enough to hang onto the mountainside, but still soft enough to grow crops in?
You can see the variety in the size of the rocks. This one here, it's up to my chest height, and yet some of them are simply the size of my hand. And what this shows me is that they really wanted to use the materials that they already had here.
Most of the terrace walls are constructed without the use of mortar to hold them together. It's a technique known as bonded masonry. And each stone was selected with the utmost care before being set into the wall.
They had men working on both sides of this wall, building alternately placed stones. This one, placed from this side like a wedge, simply banged in like this by a hammer on this side. And the alternate one, with its wedge shape here, banged in from this side here, creates a really strong wall.
But Steve can only see what's on the surface. He needs to use our technology to go beyond what his eye can see and discover the underground secrets of Machu Picchu's terraces. Steve has enlisted the help of scanning specialist Dr. Eileen Ernenwine. She uses scanning technology called ground-penetrating radar, known as GPR. It sends out a pulse-based signal, giving us the ability to detect objects and formation changes below the Earth's surface. Steve hopes this will show him how the terraces are structured and what materials they're made from.
Machu Picchu is like an iceberg. There's lots of it that's actually below the surface. And what we're trying to do with the GPR is to say, well, where's the rock? Where is the material that they started with?
To find out how they made these farming terraces, we also need the special vision of our laser scans to add to the radar data.
So we want really good dimensional data, and then really good face-on stone dating.
I don't know how we can scan and detect any rocks down in the vegetation.
If it was easy, everybody would have done it.
That's right.
That's why you get paid the big bucks.
That's right.
Right.
While the scan team is set to work, I want to find out more about the man behind the city in the sky, the Inca Emperor Pachacuti. To do this, I've enlisted the expertise of archaeologist David Drew.
Let's talk about life in Machu Picchu when Pachacuti was actually residing there. What would it have been like?
There was a permanent sort of staff, a support staff that lived there permanently, who would be notified, you know, the word would go around, right, Pachacuti's coming, you better get everything ready. It's a bit like the Tudor court, late medieval court, would go around from place to place.
The Inca believed Pachacuti to be sacred, a living god. And the mountains around Machu Picchu were also revered by the Inca. So nowhere was more appropriate to build the site than on these slopes, nearly 2,500 meters high.
This corridor from the main entrance, again, the mountain, almost like a pyramid.
Well, you're conscious of it ahead of you.
It must have been spectacular. Coming through there with that mountain and then suddenly it just opens up.
To illustrate the importance of the mountains, parts of the city are perfectly aligned with them. The city's constructed to be in harmony with its surroundings.
The architects clearly had a sense of drama, didn't they?
Yeah, it's integrating the Incas within the landscape, and that sort of statement almost of not of Inca control over nature, but sort of oneness with nature, as if the Incas are part of the natural order, if you like.
Machu Picchu is made up of two main areas, buildings on one side of the city and farming terraces on the other. The scanning team have been working hard to understand how the Incas could build viable farming land in such difficult conditions. And it's here that Eileen's GPR scanner is capturing crucial information under the ground.
That's the bottom of the agricultural soil.
Which would make sense.
And it's going down really deep.
And if there were boulders or things like that in here, we would be seeing those as, you know, quite distinct answers.
We should see them pretty strongly.
To Eileen, these lines are a wealth of information. Their thickness and distance apart shows the density of materials beneath the soil.
But it looks so perfectly horizontal. All the lines, see all the lines are horizontal in the middle of the screen.
Back in Tech HQ, Steve is examining the scans across entire terraces, and he's using them to put together a diagram showing exactly how the farming terraces were constructed.
We're actually looking through the ground here. And so what we're seeing is uniformity. We're seeing soil here in the top, then we're seeing another layer of different material, which we believe are stones of an inch diameter, something like that, and then bigger rocks down here. So they basically structured this as they went from top to bottom, much as we would do today. Wherever we look, we know that they engineered this to be a place to grow food.
The scans show how the terraces themselves have been deliberately layered. So the ground is strong enough not to subside down the mountain's steep slopes, but also contains perfect crop growing conditions.
Is the growing layer. And what happened was they structured this in a way that also enabled them to use water very efficiently.
And by creating hundreds of these terraces from the very rocks of the mountain peak, the Incas could produce plenty of food to feed the Emperor Pachacuti and his royal court of up to 1,000 people on their staple diet of maize and potatoes. But what about the terraces on the other side of the city? Their location so close to residential buildings makes Steve think these may have been built for a different purpose. He's tasked Eileen to cross over and have a look inside them with her GPR.
What I see are a lot of these large boulders under the surface. It looks like there's a lot more deeper down here.
The early GPR data is showing how this terrace is completely different from the ones built for farming in the agricultural area. To reveal more, Steve needs to get a better look at the scans in Tech HQ. Once more, the team has been given a much better idea of what lies beneath the surface.
Again, look really clear, just really higgledy-piggledy.
Yeah, completely different to the last ones. We don't see that distinct topsoil layer.
Yeah.
There's rocks right to the surface. It's a very natural sort of arrangement.
Instead of farmland, these terraces were a simple mixture of rock and soil packed together to provide the perfect foundation for building. So not only did the Inca use clever terracing to grow crops, but they also used them to strengthen the sides of the mountain, which gave stability to the buildings above.
What our data is showing us that we can now distinguish the usage of each individual terrace in Machu Picchu.
Yeah, we can.
It's amazing.
Yeah, we can.
I mean, it's astounding.
Yeah.
Advanced building in an impossible location. Our special scanning is starting to reveal a stunning perspective on the engineering marvel that is Machu Picchu. So what was it like to live within this legendary city? Residents here lived within some of the finest Inca buildings ever created, in perfect harmony with the surrounding mountains, which were sacred to the Inca. Today, experts believe that Machu Picchu was also a research station for Inca astronomers, and this vast stone may have been crucial to them, as it allowed the Inca to calculate their summer solstice for important festivals. Another of Machu Picchu's primary treasures is the Temple of the Sun. Thought to be a solar observatory, it contains some of the city's finest stonework, including this wall, said to be the most beautiful in the Americas. To find out more about the Temple of the Sun's construction, I've met up with Inca architectural specialist Stella Nair.
What blows me away is the fact that they did this without iron tools to carve these bricks. These were made from using stone hammers, weren't they?
Right, but you know, with a very simple toolkit, you can do pretty spectacular things, and Inca masonry is an example of that.
The Inca had their own methods of construction, including splitting rocks along natural fracture lines, then using stones as hammers that got progressively smaller to create a perfect finish.
These joins are so perfect, so fine, that you can't actually get a knife or a credit card or a razor blade in, depending on who you read. I'll try it out now. I've got my hotel key card, just to see if they're right. Look at that. That is bang on. Pretty good, eh? Not bad. And it's worth reminding ourselves they're not using mortar here, are they? These are just one on top of the other.
Yeah, it's perfectly bonded masonry.
The Incas aligned stones perfectly, fitting them together without the use of mortar. And they didn't have the use of the wheel to transport them into position. Steve's found evidence of how they did this hidden away.
These massive rocks took an awful lot of moving, and there was a method by which they did that, and we can see it in here. Underneath this massive stone is a stone that's been cut to a roller. So what they did when they wanted to move it sideways, they simply propped it in place, finished the bottom very flat, put the rollers under it, and rolled it into position.
The Inca used a variety of transportation methods to move stones into place, going to great effort to build a royal court fit for their emperor and his entourage. But there's one part of this remarkable site that eclipses all others with its engineering mastery: the gravity-defying summit of Huayna Picchu. With almost vertical slopes, building here would have been a whole new ballgame. An achievement probably too dangerous to undertake today. Steve wants to discover how the Incas did it. Structural engineer Steve Burrows is hoping that our special laser scanning technology will help him understand how the gravity-defying marvel of Huayna Picchu was built. For a man who deals in the modern building world, such a dangerous engineering challenge is fascinating to explore. How did the Inca, more than 500 years ago, produce such a marvel with just muscle power and simple tools? To answer this, Steve and the team are going to scan Huayna Picchu. They face a long and arduous journey to the summit, but there's no other way to get the vital scans they need.
This is not the average day of scanning, no.
Huayna Picchu's peak is 2,700 meters above sea level, nearly 300 meters higher than Machu Picchu below.
From all the way up here, you get this brilliant sense of perspective. It's exactly like stepping back from the canvas, and suddenly Machu Picchu makes sense. But more than anything, you realize just what an extraordinary engineering challenge that would have been.
But not as challenging as building up here. With limited space and sheer vertical drops, it's incredible anything is built here at all. Yet the Inca managed to construct buildings and terraces.
It's not easy to build in Machu Picchu, right? And I thought that was incredible. Yeah. But when you come here, it's almost mission impossible. I mean, these are just amazing walls. So these are a feat of engineering, much bigger than Machu Picchu, I think, because it's so dangerous.
And also the stonework is nothing like the stonework at Machu Picchu. It's a lot rougher. And obviously it's very, very solid.
But they're much smaller stones. I mean, if we just go over and have a quick look at them, you can see that most of these are the size that a man could lift. I mean, we're seeing them in Machu Picchu. They're just huge. You know, they took 10 men to lift. Just didn't work here. So everything is sort of, a bit more human scale. So I think they were really on the edge of their technology. It was very dangerous work.
It defies the imagination. I mean, here's us with all our camera gear struggling to get up here. Just imagine being an Inca having to build this. I mean, it's just...
Well, you've got to realise how high we are. I mean, this is at 9,000 feet, which is, 3 times the world's tallest building. And they're building these walls.
I mean, you were doing this now. This would be limits of engineering. Wouldn't it?
You wouldn't be able to do it. It's too dangerous. I mean, people will get killed doing this.
The sides of Huayna Picchu are covered in terracing, much like the main city. But here on slopes of such a steep angle, Steve is sure the same technique of soil and rock simply can't work. So how did the Inca build here?
We want to be able to scan inside the wall, get an area where we can actually look at all of the stones inside, so we can look at the construction behind the wall, get right inside its heart.
Much of Huayna Picchu's summit is too dangerous to scan from close up. So the only way to search for evidence is with the long-range laser scans.
So at first thought, you might think this is a staircase, but it isn't. This is simply a collapsed section of wall.
Steve has spotted a collapsed wall. It's a crucial discovery. He can now look inside the terrace to understand exactly how it was built. The scans show the whole terrace is made from solid lumps of rock. And that is the key to the stability of the terraces on Huayna Picchu.
It was all about gravity, making sure that the center of the wall and the center of gravity were in the same place, and all of the load goes straight down through the rock.
Gravity sends the weight of these heavy rocks straight downwards. With no horizontal forces pushing against the retaining wall, the terrace stays in place. If this same terrace contained soil, like the much broader farming terraces below, it could never have stayed intact for 500 years. Great horizontal forces would push against the narrow retaining wall, forcing it outwards and down the steep slope. Steve takes a closer look at how they were built.
Getting inside the wall, the main friend of the people who were building these walls was gravity. They actually built the walls solid right the way through, from here to here, and this means that it doesn't push itself off the mountain.
Our scans show how the Incas built heavy, solid terraces at the very peak of Huayna Picchu. The Incas were once more showing their mastery over the landscape.
This is really demonstrating control of nature.
Yeah.
So this is somebody saying, we're going to do it because we can. This is just an example of how advanced their technology was and what they were capable of.
Yeah.
You can start to see the terraces being formed everywhere. Yeah. So they all look the same visually,
yeah,
but every single one was specifically designed for its location.
We've seen how terraces were the key to the success of Machu Picchu's architects. But carving out land to hold up your buildings and grow crops does not make you self-sufficient. The Incas needed another crucial ingredient. Without it, life can't exist.
The Incas had another problem to overcome before they could even think about building anything here, and that is they would have needed a fresh supply of water like this. Without it, Machu Picchu would never have happened.
Part of the mystery of Machu Picchu is how the Inca could provide running water to an entire city on the top of a mountain. They would have needed a supply for up to 1,000 inhabitants. This wasn't just a basic well system. The Inca actually created plumbing for the whole settlement to access running water. To show us just how efficient that system was, I'm meeting Inca expert Peter Frost.
Let's get some of that water. This is very good water.
This is what they would have had to have done. That's pretty heavy.
This is just one of a network of water fountains throughout the site, and they were all connected by a series of drains which snake down the mountain. At the top of the mountain, the very first fountain flowed directly into the private quarters of the Emperor Pachacuti.
The king had to be the first to get the water. His palace had to be right there where the...
Right at the top, so the cleanest water, the first water, the Pachacuti's going to get first.
Yes.
He's the most important. And as it flows downhill, then some of the other people can...
Absolutely, yeah.
The requirements of the emperor and the city weren't small. Pachacuti didn't just use the water to drink from. He had a specially built bathing area. And below him, the entire city would have required thousands of litres of water to survive. Most settlements throughout history have been based next to a supply of water, often a river, much like the Urubamba River, sacred to the Incas, which flows past the town at the foot of this mountain.
I think to really understand the Incas, to get inside their minds, you have to appreciate their deep connection with the natural world, with all of this, the mountains and the sun, and not least this, the mighty Urubamba River.
For a town at the bottom of the mountain, a river of this size would give the Incas all the water that they needed to survive. But how, nearly half a kilometre above, could the city of Machu Picchu find enough water to allow its residents to live? For Steve, this is a fascinating engineering question.
What I want to know is, where does the water come from? Because when I can find that, I will know exactly the point where Machu Picchu was born.
Steve and the team set to work locating the Incas' water supply. Their quest takes them to a slope nearly half a mile south of Machu Picchu, where Steve hopes he can locate the source. The route is hazardous. It isn't open to the public, and very few people ever make the journey. It's covered in dense vegetation, and machetes are needed to clear a way through. After the trek, the natural spring comes into view. Steve has found what he's looking for.
This is the start of the water source that serves Machu Picchu. I can actually see the water coming from a rock up there. If I remove some of this undergrowth, you can probably get to see it yourself. The water flows down here and into this channel and down into Machu Picchu. This is the reason Machu Picchu exists.
Inca expert Peter Frost has joined us on the journey.
It's draining off a high mountain slope behind us. But more than that, you know, it's draining out of a fault in the rock.
A sort of geological anomaly that really means that there's so much water at this location.
It is.
The Incas needed more than just a mountain spring to provide water for an emperor and his court almost a kilometre away. They needed to harness the supply. To do this, they built a cistern to collect the water and a canal to transport it to the city. So just how much water could this system have provided?
The amount that's coming here is absolutely vital to the size of the city that can exist. What I want to do is see if we can actually find a way to assess the amount of water that was available to the people of Machu Picchu.
And to find out how much water flows into the city, Steve needs the team to scan both the canal that carries the water and the cistern itself.
Was the spring, do you think, the reason they built Machu Picchu here?
Oh, absolutely. In order to live, they needed this, and they knew there was a source of this, and they used it wisely.
What can we find out with our equipment?
We're going to create a dam for a temporary period, and we're going to let the water level rise. We're going to measure how much it rises in what period of time. Then we know what the volume of water is that's coming down this channel. Yeah. We can then survey the channel and the gradient, and we can calculate how much water came out at the end.
So, and no one's done that before. No one knows the answer to this. I mean, people have ideas. But
there are estimates.
Yeah,
but we're going to be able to do it.
But it won't be easy. The team will have to scan a canal that's half a mile long and covered in dense vegetation. It's the toughest challenge so far for the scanning team.
Here's what we need to scan the channel all the way out.
Yeah.
5 good workers, 2 chainsaws, 3 weed eaters, about 10 scan targets, and around 2 weeks.
Right, so here's what we've got. We got 3 scanners, we got 3 machetes. So what can we do?
We can try.
We'll see.
By scanning the cistern and canal, Steve hopes to work out exactly how much water flows into the city on a daily basis. Malcolm begins by figuring out a way to calculate the size of the cistern. Scanning through water, though, is notoriously difficult.
This has probably been one of the harder scan tasks I've been assigned. Determining the volume of this basin accurately is going to be the tough part.
Back towards the city, Katie and Adam are scanning the canal to get its exact length and gradient. And they have the problem of scanning through undergrowth to deal with.
You couldn't do that with your bamboo stick. Why not?
Yeah, I could.
Lack of muscle, huh?
No, I was gonna. I just didn't know if they wanted me to cut all that down.
As the day draws to a close, scanning is nearly complete. And Steve catches up with the team to see how they've done.
Hey, Adam, so you accepted Mission Impossible and then went and did it?
It has been accomplished.
The team has managed to scan the entire water system. With this data, Steve now hopes to calculate exactly how much water was available to the Incas for their city in the sky. We're discovering the engineering secrets of the Inca and the gravity-defying city of Machu Picchu. Structural engineer Steve is on a mission to work out how much water was available to Emperor Pachacuti and his royal court. For this final task, he's asked his scanning team to ditch their lasers and go back to basic technology to make some new calculations. He can then crunch the numbers in Tech HQ.
So what I asked Malcolm to do then was create a dam, and we measured how much time it took to build up through a certain height. I mean, this was an impossible task.
This is like the best homework I've ever seen.
Then using a piece of bamboo, which Malcolm marked the level, he let it fill, timed it, and put another notch in the bamboo. Yeah. So based on the combination of laser scanning and notches on bamboo, we calculated the volume of water that's coming into Machu Picchu.
Were the people of Machu Picchu forced to ration their supply? Or had they found a way to harness the mountain spring and give them water in abundance?
Let's have the number.
The answer is that we're getting about 49 litres every minute. So we're getting about 10 gallons of water a minute coming into Machu Picchu.
Incredibly, our data shows that in the rainy season, there's around 70,000 litres of water flowing into Machu Picchu every day. For a population of 1,000, that's over 70 litres per person. Today, we use around 50 litres per person per day. So Steve thinks the Incas had plenty for their needs.
We don't know whether Pachacuti liked a bath or a shower or turned the tap off when he was doing his teeth,
But we know how much water they had to start with.
The canal system is one of the Incas' greatest engineering achievements. With the individual scans now joined together, despite the data being patchy because of the dense vegetation, Steve can follow the path of the water as it snakes from almost a kilometre away right into the heart of the Inca mountain city.
This wasn't a simple exercise. To keep the gradient as constant as possible, they had to follow the mountainside, and so they were constantly going through the undergrowth. Just looks like a giant snake.
Our scans show that from leaving the cistern to reaching the city, the canal's elevation drops by nearly 16 metres.
So now we've stopped all that snaking. Let's follow it right down to fountain number 1.
There it is.
With an Inca would have had that really high-quality water.
From leaving the dense jungle to reaching the first water fountain, the canal's elevation drops further still, allowing the water to flow into the city slightly faster. This shows just how precise Inca engineering really was. Any steeper, and the water would burst its banks. Any shallower, it would flow too slowly and never reach the city.
Despite the immense effort of building this place, life ended here very abruptly. Within a century of the first stone being laid, the whole place was abandoned, consumed once again by the forest, and hidden from the outside world for almost 500 years.
We've seen how Machu Picchu was a luxurious royal retreat, fit for the emperor of the largest empire in the world at that time, achieved without the use of the wheel or a written language.
I think the Incas are particularly intriguing, partly because we don't have that first-hand written history to rely on. So much of their story is tied up in the stones themselves, and it's our new technology that's really helping to tell that story with a greater clarity than ever before.
And what a story it is. Using our state-of-the-art laser scanners, we've been able to look at this awesome human achievement with a brand new perspective. We've seen how it was constructed on top of a mountain, and how the sheer slopes evolved into tailor-made terracing, supplying the city with an abundance of fresh produce. And now we know that every resident had access to up to 70 litres of water per day. That's more water than up to 1 billion people in the world today have at their disposal. Steve's realised the Incas built this ingenious place by embracing their environment.
Machu Picchu feels totally in harmony with nature. It's a sort of mystical place, so it still feels like part of the mountain from which it was born.
This city is a realisation of the near impossible. A fully functioning city in the sky, and a lasting monument to some of the greatest engineers the world has ever seen.